So whenever you have a number, try to get rid of your fraction. Find your common denominator. Find your common denominator and get rid of it. That's the easiest way. These are terms. So multiply each term by your denominator. Again, put it right next to it. The book did it the way I did, so I just copied theirs. Probably you could read this a little bit better. So solve and check your solution. But at least when you know there's no domain restrictions, you know it didn't interfere with any fractions. This one again, if it helps, put everything over 1. Find your common denominator. So your least common denominator is 12. Put 12 on the top of every term and multiply. It will cancel out your fraction. If at this point you didn't get rid of your whole fraction, you didn't have a common denominator. And then work through. Okay, stop me if you have any questions. Easiest way, cross multiply. You do have a domain restriction. You have a variable in the denominator. So my answer cannot include -4/5. If I come up with the answer -4/5, it was not allowed, I was not allowed to use it. Okay. So cross multiply, multiply both sides by 5x plus 4, whichever you like there. Cross multiply is probably the easiest. And solve. Factor everything first before you even attempt your denominator. Factor it. So you've got an x minus 3 and an x plus 3. Therefore, set both of those equal to 0. You cannot use a 3 or a -3 when you get your answer. If this comes out to be 3 or -3, I know right away there's no solution. I can't use that in my denominator. Find your common denominator, put it on the top of every term. So you can cancel out your common factor, and then you're left with whatever's left here. These were nice because these were both 1s. So when you multiply by 1, you just keep the x plus 3, x minus 3, and we get rid of the 10. Get rid of your denominators. On an equal sign, you can. On an expression, you cannot. An expression, you have to keep your denominator. This one, 2x plus 1 and 2x minus 1 is your common denominator. Set them both equal to 0. So your domain restriction is plus or minus 1/2. You cannot use plus or minus 1/2. Okay. Again, put it on the top of every term. Just go like this. 2x plus 1, 2x minus 1. 2x plus 1, 2x minus 1. Oops. Don't forget this side. So this is going to cancel out. You're going to multiply by 2x minus 1. The 2x minus 1 is going to cancel out. You're going to multiply by 2x plus 1. This one you have to multiply the whole thing. Probably easier if you do your perfect squares. First terms, last terms. And then multiply by 4. Whichever one you decide to do. And 11/6 is from our allowable domain. If you're feeling a little rusty, it'll come back.
Can you go back?
Oh. Yes. Again, my numbering is a little off on these because my last year's group didn't want to take it out of the book, so I had to just cut and paste them onto a worksheet real fast. I didn't want to take their book home or leave it home. So I think the problem was if they left their book home and they did their homework in school, unless they didn't have a book to do their homework. So I think that was the reason we went to the worksheets, which is a little more paper, but it's okay. Okay. Everybody find the common denominator? Everybody okay with that? Okay. All right. X is equal to 0 and x is equal to 5 will cause our fraction to be undefined. So we have to take those out of our allowable domain. Again, if you start like this, if you forget how to do this, start here. Take these guys out. You're using everything here, and everything here in your allowable domain. Find the common denominator, and that's not from your restrictions, so you should be pretty good. Again, when you multiply by 0, that's kind of nice. Still 0. This guy. We have a couple of things, an x and an x minus 3. Those are your factors that you're going to need for your denominators. Set them equal to 0, take out your domain restriction, and use your common denominators. They put it to the side. I usually just put it right on top because it makes life easier. You can just cancel them out. This is coming out, you're left with plain old 3. This is coming out, you're left with 4 times x minus 3. This guy's coming out, you're left with 1 times x. So when you get to here, you should have no fractions left. If you did, that means you didn't get your least common denominator. You probably left out one of the factors. Now, when we get down here and we solve, we get x is equal to 3. But we're not allowed to use a 3. That's not in my allowable domain. So therefore, it's an extraneous root. And it's the only solution I had. So not only do we reject it, but we say no solution. You don't have to tell me it's extraneous, you just have to say no solution. Questions? Very good. So all coming back to you? Kinda? Eventually it will. Okay, yesterday we started to do one of these and we said don't forget to get the y's in there as well. So these you have 2 lines. 2 lines can intersect once, or they can be parallel and never intersect, or they can be the same line and have infinite solutions. And in this case, they have one x value with crosses once. You can confirm it on your calculator, y1, y2. And don't forget to go back and find the y. You just take either one of these equations, whichever one was easier, and whichever one you want to use. Let's take this one. So if x is 1, just take this one, and now you have your solution set. Whichever one you like, they're both set equal to y, so whichever one you find easier. Remember, you have 2 lines, and where they cross is a coordinate point. So you're going to need an x, you're going to need a y. And we had no domain restrictions on our 2 lines. So set both of these equal to y. We have a line, and what is this one going to give us? What's this function going to give us? A parabola. So a line can cross a parabola once, it could be tangent to it, twice, or not at all. So in this case, we came down and we had 2 values of x, right here. X is equal to 2, x is equal to -1. In both cases, I would probably bring down the 1. Plug in your -1 and get your 3. Plug in your 2 and get your 6. Good. And confirm it on your calc. Once it's y equal, put it in your calc. Can you solve for x and plug it into this guy? Yeah, probably take a little longer because you have to square it. That's fine. Solve for y and then plug it into this one. Absolutely, just watch your negative sign. I tend to be, whenever it's a y equals, I tend to use y equals. But whatever works for you, just be careful. This one would have to be squared. This one would have a negative in front of it. Okay, we have two lines here that cross. Could cross once, not at all, or it can be the same line. No domain restrictions, and we cross that for 1. And the last one is the graph. Did I give you this one? The graph is like a W on the calculator? Ah, you know how to put it in your calc?
Yeah.
Okay. Yeah. Yeah. Okay, any questions on this? Did you have to solve it graphically or algebraically? Graphically. So all you had to do was put it in your graph. So go to your y equals and plug in the first one, which, can you tell me what, oh, there it is, 2x squared. And plug in the second one, x to the 4th. It gives us a w. We're going to be working a lot with these. Okay, and graph it. There's your parabola. That's the squared one. And there's your to the 4th power. So you're crossing right here. And if you look at your table, probably easier to look at your table because it looks kind of jumbled up there. Look for your y's to be the same. So it's happening in the positive, it's happening at the 0, and it's happening in the negative. See it? We do a lot with these. As high as your exponent is, that's how many roots you have. So if this is an exponent of 4, it's going to have 4 roots. It's going to cross that x-axis 4 times. Here's 1, here's 1. But this one is called a double root because it bounces off the axis. So this counts as twice. It's like the square root of 0. We really don't have a plus or minus, but it's a double root. And if you get 4 roots, you get minus 1 3 terms. So 1, 2, 3. And we do inflection points. And we do a whole lot with this stuff. And we'll be able to graph that without a calculator pretty soon. Good? 54. I don't really have, I was going to do the next one, but I don't really have a lot of time because we spent some time setting up Edmodo. So I will probably give you the weekend off.
Sweet.
So that will be your favorite teacher this weekend. Next weekend you will have a church out. This weekend you'll be your favorite teacher. The last thing I want to do is channel that